What's going on, everybody? Welcome back to another video. Today we're going to demystify the differences between a database, a data warehouse, and a data lake. It's going to be simple, clear, and super useful. So stay tuned. As always, please give it a like, subscribe to the channel, and hit the bell icon so you don't miss future videos. It really helps support the channel and keeps the educational content coming. Thanks so much. Let's start with database. A database is an organized collection of data that is stored and accessed electronically. It allows users and applications to efficiently store, retrieve, update, and manage data. Here are some key concepts for database. Structured data. Structured data is data that adheres to a fixed schema, so all of the data has the same fields or properties. In other words, the data is represented in one or more tables that consist of rows to represent each instance of a data entity and columns to represent attributes of the entity. Similar to spreadsheets. Database management system. DBMS software like MySQL, PostgreSQL, Oracle, or Microsoft SQL Server that manages the database and provides tools to interact with it. Querying. You use languages like SQL, which is structured query language, to perform operations such as insert, which is for adding new data, select, which is for getting data, update, changing data, delete, for removing data. There are mainly two types of databases. Relational databases, RDBMS. Relational databases are commonly used to store and query structured data. The data is stored in tables that represent entities, such as customers, products, or sales orders. The tables are managed and queried using SQL, example, MySQL, PostgreSQL. Non-relational databases or NoSQL databases. Non-relational databases are data management systems that don't apply a relational schema to the data. Non-relational databases are often referred to as NoSQL database, even though some support a variant of the SQL language. It stores data in formats like key-value pairs, documents, or graphs. Example: MongoDB, Redis. Examples: banking systems use databases to store customer account info. E-commerce sites use them for products, orders, and customer data. Social media platforms use them to manage posts, profiles, and messages. Let's quickly break down what a data warehouse is and why it matters in simple terms. A data warehouse is a special kind of database. But instead of handling everyday transactions, it's built to store and analyze huge amounts of historical data. It's mainly used in business intelligence. That means reports, dashboards, and strategic decision-making over time. Now, what makes a data warehouse unique? Here are the key traits. First, it's subject-oriented. That means it's organized around big-picture business areas, like sales, finance, or customer behavior, not day-to-day operations. Second, it's integrated. A data warehouse pulls information from all kinds of places, spreadsheets, databases, CRM tools, and combines it all into one consistent view. So everything makes sense in one place. Third, it's time variant. It keeps track of historical data, so you can see trends over time, compare performance across months or years, and make data-driven decisions. And fourth, it's non-volatile. Once data is loaded in, it's not usually updated or deleted. It stays there for analysis, so it's consistent and reliable. Now, let's talk about how a data warehouse actually works. What are the moving parts? The first big part is the ETL process: extract, transform, load. This is how data gets from your source systems into the warehouse. Extract means pulling data from different sources. Transform means cleaning it up, reformatting it, and organizing it. Load means saving it into the warehouse, ready for analysis. Next, you have the data warehouse database itself. This is where all the structured data lives, nice and clean, ready for fast querying. And finally, OLAP tools, that's online analytical processing. These tools help you run complex queries, slice and dice your data, and build reports or dashboards with multiple views, fast and efficiently. So, to sum it up, A data warehouse helps organizations turn raw data into meaningful insights by bringing everything together, keeping it consistent, and making it easy to analyze over time. Let's clear up the difference between a database and a data warehouse. Quick, simple, and with real-world examples. First up, the purpose. A regular database is used for everyday tasks like recording sales, tracking orders, or updating customer info. It's all about running the business day to day. A data warehouse, on the other hand, is built for analysis, helping you make big-picture decisions based on long-term data. Next, the type of data. Databases store current, real-time data, what's happening right now. Think of it like a live feed, while data warehouses store historical data, summarized over time so you can look back and spot trends. What about performance? Databases are optimized for fast inserts and updates because the system is constantly changing. On the other hand, data warehouses are tuned for fast querying and analysis, so you can run reports and dig into the numbers without slowing things down. And finally, who uses them? Databases are mainly used by employees and apps that need quick access, like point-of-sale systems or CRMs. Data warehouses are used by analysts, managers, and execs who want insights from the data, not just records, but patterns and outcomes. So, quick recap. Databases keep your business running. Data warehouses help you understand how it's running and how to improve it. All right, let's talk about what a data lake really is and why it's so useful for modern data projects. First, raw data ingestion. A data lake takes in data in its raw, original form. No need to clean it or format it first. Just dump it in, straight from the source. Next, support for all data types. This is where a data lake really shines. It can handle anything, structured data like tables, semi-structured like JSON, and even unstructured stuff like images, audio, or log files. It's like a massive digital storage bin for every kind of data you can imagine. The architecture is flat. That means it doesn't organize data in complex folders or tables. Everything sits in one big storage layer, super flexible, but it needs good governance to keep things under control. Now, schema on read. Instead of defining a structure when data is stored, like in a database, you apply the structure when you read it. That gives you way more flexibility when you're exploring or analyzing different data sources. Size, it's big. Data lakes are designed to hold massive volumes of data, way bigger than your average database or warehouse. It's meant to scale with your business or research needs. And finally, processing before use. Because data goes in raw, you need to process or clean it before you can use it for analytics, reporting, or machine learning. So it's not plug and play, but it gives you the full power to shape and explore your data however you want. So in short, a data lake is your go-to for storing everything in any format at scale, but you'll need to process it before turning it into insight. Let's quickly break down the difference between a data warehouse and a data lake. First up, data type. A data warehouse stores only structured data, things like tables with rows and columns. A data lake, on the other hand, can store everything, structured data, semi-structured like JSON, and even unstructured stuff like videos, images, and logs. It's much more flexible. Next, schema. With a data warehouse, the schema is defined before you store the data. That's called schema on write. In a data lake, you apply the schema later. When you actually use the data, that's schema on read. It gives you more flexibility, especially for raw or messy data. Storage cost. Data warehouses are generally more expensive. They're optimized for performance but not built for bulk. Data lakes are cheaper because they store raw data in bulk using low-cost storage options. Purpose. Warehouses are built for business intelligence, dashboards, reports, and curated data for decision-making. Data lakes are designed for data science, machine learning, and deep analysis. You work with raw data and explore freely. Performance. Warehouses are fast. They're tuned for quick SQL queries and real-time analytics. Data lakes aren't optimized for speed until you process and prepare the data, so it can be slower at first. Users. Warehouses are typically used by business analysts and decision-makers. Data lakes are mostly used by data engineers and data scientists who need access to all kinds of data formats. And finally, Data processing. Warehouses use ETL, extract, transform, then load. That means data gets cleaned before it goes in. Data lakes use ELT, or just raw ingestion, load everything first, and clean it later when needed. So, to sum it up, data warehouses are clean, fast, and structured, perfect for reporting. Data lakes are raw, flexible, and powerful, ideal for experimentation and advanced analytics. Thanks so much for watching. I hope you found this helpful. Looking forward to seeing you in the next video. Until then, take care and keep learning.